Before we go on to look at question 4, there's a couple of truth tables that we need to have a look at. So the first one is looking at the inclusive disjunction P or Q. So we have our standard truth table here where we've got two statements P and Q. Now the inclusive disjunction P or Q is basically saying, is one or other or both of the statements true? That's all it's saying. So if we look at the first instance then, P is true and Q is true. So is either one or both of those statements true? Yes. So therefore the inclusive disjunction P or Q is true. If we look at the second row then, P is true, Q is false. So is one or both of those statements true? Yes. So P or Q is true. Third row then, so P is false, but Q is true. So again, therefore, is one or both of those statements true? Yes. So therefore, the inclusive disjunction P or Q is true. Finally, in the fourth row, is P or Q true? Well, we don't have either of these statements being true. So therefore, the inclusive disjunction P or Q is false. Similarly, we now need to look at the connective here, which is an implication. So P implies Q. Now, this one is slightly confusing. It's probably the most problematic of all the conjunctives. Now, what this connective actually is saying is, if P is true, then Q should also happen. So the easiest place to start for this particular connective is what happens here, right? Because our connective is saying, if P happens, then Q happens. But in this instance here, P doesn't happen. So we have no idea what should happen. So whenever you have P being false, you don't have enough information about what should happen, so we can't falsify it. So if the statement P is false, straight away the connective here is true. What we can do now then is have a look at the first two statements. In the first statement, we've got P is true. Now, according to the connective here, if P is true, we should also get Q. And we can have a look here that we do get Q. So this conforms to the implication. So this is true. In the second line, though, we can see that P is true. And again, we know from our connective we should get Q. However, we don't. We get false. Therefore, this statement this contradicts the connective. And this is the only instance where we'll end up with false in the final column. Now, if we stick with that, we can actually use this for some definitions as well. So if we stick with the connective P implies Q, inverse simply means that you are going to negate this argument. So if you're asked to find the inverse of P implies Q, you're just simply going to negate that. So the inverse would be, if P implies Q, then not P implies not Q. The converse means you're going to switch it the other way around. So if P implies Q, then the converse would be Q implies P. And the final contrapositive is in effect both. So if you had P implies Q, the contrapositive of that would be not Q implies not P. So all those are relevant in this particular instance. So in the first question we're asked to write down in words, Q or not R implies P. So Q is the car is less than 2 years old, not R. So if R is the car has been driven more than 20,000 kilometres, not R has not been driven more than 20,000 kilometres, and P is under warranty. So in words, what this effectively means is, if the car is less than 2 years old, or the car has not been driven more than 20,000 kilometres, then the car is under warranty. And then we can go through and complete the truth table. So in this column here, we are again looking at the inclusive disjunction. So we're looking at Q or not R. So we're looking at these two columns and we're saying, like we just looked at in the previous example, is one or both of them true? So yes, one of them is true. Yes, both of them are true. Neither of these are true, so that's false. One of these is true, so that's true. One of these is true. Yes, both of these are true. Neither of these are true, so that's false. And one of these is true, so that's true. Now we're looking at this connective here. So we're saying, if this is true, we should have P. So remember from the previous example that this here tells us what should happen if Q or not R is true. It doesn't tell us anything about what should happen if that's not true. So we're going to look at this column, and we're going to look at all the examples where this is not true. So here, this is not true, and straight away we're just going to put true, because we can't falsify that. We have no information about what should happen if that's false. So that's going to be true, and that's going to be true. Now we can go back through and look at if each of these adhere to the connective. So if that's true, we should get P. Let's have a look at P. P is true, so that conforms. Secondly, true here, we also get P, so that conforms. True here, so that also conforms. Now in this row here, Q or not R is true, however, P is false, so we can say that that's false. Similarly, here we've got true in this column, and that's also false, so we can say that's false. And finally, in this column, we've got Q or not R is true, and in the P column, P is also false, so we can falsify that. So that is going to be the truth column for that. And finally then, state whether the statement not P implies not Q or not R is the inverse, the converse, or the contrapositive, whereas we saw that's kind of both the wrong way around and negated, so therefore that is the contrapositive.